Hello guys and girls, in this video I will tell you about astrophysics as a science. Astrophysics is a branch of astronomy that studies all the diversity of physical and in part chemical phenomena in the universe. Astrophysics studies celestial bodies, their physical and chemical, in collaboration with cosmochemistry phenomena. Some areas of astrophysics include attempts to describe the properties of dark matter, dark energy, black holes, and other astronomical objects. The main direction, according to the object of study, are the physical of the Sun, planets, exoplanets, black holes, interstellar mediums, and nebula stars cosmology. History. Astrophysics began its development with the discovery of spectroscopy in the 19th century, which allowed astronomers to analyze the composition of stars by the light they emit. Current state. Astrophysics sees the universe as a vast laboratory in which they can study matter at various temperatures, pressures, and densities that are unattainable on Earth. Astrophysics is the experimental and theoretical study of the structure of stars and stellar envelopes, the interstellar medium, corpuscular and electromagnetic, radio, thermal, optical, X-ray, and gamma radiation from planets, the sun, stars, and galaxies, the motion of stellar systems, and cosmogony models. Astrophysics is also a branch of astronomy that studies the physical state and chemical composition of celestial bodies and the interstellar medium, as well as the processes that take place in them. As an independent branch of science, astrophysics began to develop in the mid-19th century in connection with the progress of physics, especially with the discovery of spectral analysis and the use of photography. At the beginning of the 20th century, the development of the theoretical physics, in particular the theory of radiation and atomic physics, as well as the rapid growth of observation technology, become a prerequisite for the intensive development of astrophysics. The main sections of astrophysics. The main section of astrophysics: solar physics, physics of stellar atmospheres, physics of gas nebulae, the theory of the internal structure of stars, physics of planets, ethics. Practical astrophysics develops methods for studying celestial bodies. One of the sections of practical astrophysics is astropolarimetry. Theoretical astrophysics uses the results of those studies to elucidate the physical nature of celestial bodies. Areas of research. Theoretical and experimental research in the following areas: elementary particles and fields in astrophysics, models of the universe, the origin of the elements, space electrodynamics, gas and magnetohydrodynamics, formation of stars and galaxies, internet structure of vision, atmosphere of vision, peripheral shells, variable stars, double and multiple stars, stars cluster associations, interstellar medium, molecules in the interstellar medium. kinematics and dynamics of stellar systems, structure and evolution of galaxies, quasars, ciphers, and other types of galaxies, clusters of galaxies, metagalaxy. Thermal radiation, cosmic rays, radio radiation or supernova remnants, radio radiation of the moon, planets, and the other bodies of the solar system. Solar radiation, radiation sources in the galaxy, the structure of the galaxy according to radio date, discrete and extant sources of radio radiation, radio galaxies, methods, tools, and physical and mathematical principles of equipment for astrophysical and radio astronomical research. Methods. Among the methods of astrophysics, astrometry is of great importance, the task of which is to measure the location and brightness of celestial bodies with the help of visual photographic and photoelectric observations. Astrospectroscopy plays an even greater role in astrophysics. The study of the spectra of celestial bodies makes it possible to draw conclusions about the chemical composition and physical state of matter on those bodies, determine the temperature of stars, calculate the speed of approach or removal of stars, draw conclusions about the relation of stars, various physical processing occurring in the Sun and stars gas nebulae and in the interstellar medium. In connection with the launch in the USSR of the first artificial satellites Earth and Sun, astrophysics has acquired new research methods. The equipment installed on the satellites makes it possible to record the radiation of celestial bodies far beyond the Earth's atmosphere. One of the most important achievements of astrophysics is the conclusion about the unity of matter in the universe. The various celestial bodies consist of the same elements that exist on Earth. Helium gas discovered in 1868 by the Sun was also discovered on Earth in 1895. For a long time, scientists believed the gas nebula included the element nebullium, the source of several spectral lines that are not observed in terrestrial conditions, but in 1927 it was proved that those so-called nebular lines are forbidden lines of doubly ionized oxygen. In the spectrum of the solar corona, bright coronal lines are observed, which for a long time could not be identified with the lines of known chemical elements. As it turned out, they do not belong to the hypothetical elements chrome, but iron, nickel, and calcium in high degrees of ionization. Astrophysics has discovered a great variety of stars in the stellar world. Stars differ in temperature, luminosity, size, and other characteristics. The classification of stars is based on a comparative study of their spectra. A chain connection has been established between the spectra of stars and their luminosities, which is clearly represented by the Hertzsprung-Russell diagram. Most stars are located almost diagonally on the chart, forming the so-called main sequence. However, a significant number of stars do not fit in fit into the main sequence and form special classes. Those are, for example, the classes of relatively cold stars, the classes of gigant and supergiant, and so on. The glass is very interesting. White dwarfs, hot stars of relatively small size with every high density. There are many double stars, multiple stars, and variable stars of different types. Of particular interest are the new stars, which suddenly flash and amplifying their radiation tens of thousands of times. Astrophysics has made great strides in studying stellar atmosphere, including the solar atmosphere. In the lower part of the solar atmosphere, the photosphere, there is radiation with the continuous spectrum in the transforming layer located above it. Complex processes take place under the influence of which dark absorption lines appear in the spectrum of the Sun. Fraunhofer lines above is the chromosphere, the outer part of the solar atmosphere. The solar corona is very extensive formation which during complete solar eclipses is observed in the form of a silvery glow. Some properties of the solar corona, which for a long time seemed mysterious, are due to its high kinetic temperature, reaction millions of degrees. Processes in the solar atmosphere affect the geophysical phenomena. The internal structure of the Sun and vision can be calculated theoretically based on the laws of mechanics and physics. Calculation shows that the temperature, density, and pressure of stellar matter increase as we approach the center of the star. See equations in the internal structure of stars. The source of energy for most stars in the main sequence in thermonuclear reactions, in which hydrogen is converted to helium. Of great interest are non-stationary stars, in which changes in physical properties occur relatively quickly. The study of those stars is the basis for solving the problem of stellar evolution. The physics of gas nebulae, especially planetary ones, has developed significantly. Their glow is caused by fluorescence under the influence of hot star radiation. Astrophysics has achieved important results in the study of planets. In particular, the study of the surface of Mars has provided an opportunity to approach the solution of the question of life on this planet. Astrophysics successfully studies the physical characteristics of comets. The study of meteors is not only astrophysical but also geophysical interest because it is associated with the study of the upper atmosphere. Astrophysics in the Soviet Union. Soviet scientists made a great contribution to the development of astrophysics. The name of F.A. Bredick, I.A. Belopolsky, G.A. Tikhonov, V.G. Feleskov, C.V. Orlov, and many others are associated with the development of the main selection of the astrophysics. Academician V.A. Bertuzmian and his students performed basic research in the study of gas nebulae and stellar atmospheres in the theory of light scattering, physics of non-stationary stars, and in other fields of astrophysics. Great successes have been achieved in the study of processes on the Sun. E.R. Mustel, A.B. Sereny, V. Ogre, G.S. Shklovsky, and others. In the study of planet G.A. Tikhov, M.P. Barabosov, and others. The interplanetary environment, V.G. Fersinko, and others. The leading research institution of the USSR in the field of astrophysics were the Chemian Astrophysical Observatory of the USSR Academy of Sciences and the main Polkova Astronomical Observation of the Academia of Science, the Astronomical Institute, Sternberg, Moscow State University, major national observatories, Abaistrum, Georgia, Burakan, Armenia, the main astronomical observation of the USSR Academy of Sciences, and the others, as well as astronomical observatories of Leningrad, Kiev, Kazan, Kharkiv, and Odessa University. That is all. Thank you for watching. Goodbye.